Hello and welcome to the course Introduction to the Psychology of Bilingualism and Multilingualism. I am Dr. Ark Verma from the Department of Cognitive Sciences at IIT Kanpur. This is the fifth week of the course, and I just needed to conclude the chapter on comprehension processes in bilinguals and multilinguals. As you know, so far we have talked about the aspect of parallel phonological activation in bilinguals across their two languages, but most of the research that we have actually reviewed has used the presentation of visual stimuli, basically using the visual word recognition task or the lexical decision task. Now, an interesting aspect of visual stimuli is that in order to be able to read the visual stimuli, you will need to convert the orthographic representation to a phonological representation, and then the phonological representation basically searches for the matching representation into your mental lexicon, maps it to meaning, and so on. However, this conversion is basically an indirect one in terms of how the bilingual's mind processes the input from two languages. In that sense, it might be important for us, it might be helpful for us to actually look at some of these studies which are evaluating parallel, or which are demonstrating parallel phonological activation in the bilinguals using the auditory presentation of stimuli. Indeed, a bunch of studies have presented auditory stimuli for investigating parallel phonological activation in the bilinguals. Most of these studies have used the eye movement tracking paradigm, which was initially developed by Tannenhaus, Spivey, Knowlton, Eberhard, and Sedewey, that allows the investigation of online language comprehension. Now, this paradigm is typically referred to as the visual world paradigm, and in this visual world paradigm, typically what happens is that a participant is presented with auditory instructions and they have to react to the stimuli, trying to understand the auditory instruction at the same time. For example, I could tell you, oh, lift that bucket for me. Say, for example, if I'm showing you a stimulus, I could basically, if I'm showing you a stimulus, let's say it is composed of a table top, and the tabletop contains 4 objects. I could basically look at you and I could tell you, oh, pick up that red apple from there, or pick up that apple on the napkin, or pick up that apple on the towel. Basically, what it will allow you to do, or basically what it will trigger you to do is, if you are understanding the auditory instructions carefully, your eyes will move on the table. It will basically go from object 1 to object B, depending upon whatever the target object is in my set of instructions. At the same time, while the participants are going through the experiments in the visual world paradigm, they are wearing a headband, and the headband basically carries equipment that can track their eye movements on the visual display. Now, there are 2 versions of this visual world paradigm that are possible. In one kind of version, which is some of the older studies, where actual real tabletop kind of displays have been used and participants' eye movements have been tracked across real objects. In later studies around 2004 and afterwards, when Jerry Altman and their group sort of took to the visual world paradigm, these studies could also be done using a computer representation, where you basically have to move your cursor of the mouse on the visual display. Let's say if the visual display is divided into 4 quadrants, A, B, C, and D, and in response to the instructions from which you are hearing on the earphones, you basically have to move your cursor from point A to point B to C, and so on and so forth. Basically, what is happening here is that the experimenters are actually checking your online comprehension of the instructions, and basically looking at how your eye movements are changing in response to these instructions. Now, for monolinguals, this will be interesting, because every time a monolingual is trying to understand or hear or follow spoken instructions, they are basically going to understand those instructions only in the terms of a single language, and therefore there will be less of confusion and less of indecision, for example, due to the parallel phonological activation of the 2 languages. However, if bilinguals are doing this, if bilinguals are trying to understand the comments and basically follow those instructions being delivered through their earphones, they will basically need to understand, or they will basically need to to handle the input that is coming from or the input that is being matched to their two parallelly or co-activated mental lexicons. This is basically assumed to take a little bit more time than a monolingual, and depending upon whether or not remember that I've just told you a hypothetical scenario that if parallel phonological activation happens, this is what we should see. But depending upon whether parallel phonological activation across the two languages is happening or not happening, we can see that the bilinguals will take little less or more time in following the instructions and, let's say, moving the cursor around the computer screen or moving their eyes on the tabletop display towards target objects. With the help of this technique, Tannenhaus and colleagues have actually gathered temporal information about the process of spoken language comprehension. Now, using these studies, the authors have found that the visual context really affects the resolution of temporary syntactic ambiguities. Now, what are temporary syntactic ambiguities? You might have heard of garden path sentences in one of my previous lectures on psycholinguistics. Garden path sentences are basically sentences where the thing is, where the exact meaning of the sentence is not very clear because it is ambiguous. Say, for example, the horse that raced past the barn fell. Now, if you are listening to this sentence, you are not going to be sure about what actually fell. Did the barn fall down or the horse fell down, and so on and so forth. So these are some examples of temporary syntactic ambiguities, and basically what these researchers using the visual world paradigm have sort of done is that they have utilized these temporary syntactic ambiguities tap into the online comprehension process of bilinguals. The idea is that the bilinguals actually use or take the help of the visual context, let's say the display that is in front of me or the visual screen that is in front of me, to basically resolve these temporary ambiguities. For example, if I have a display and in this display there are a bunch of objects, suppose one of these objects is a candy bar, another object is a candle, another object is a tablet, another object is a bottle. Now, if I'm giving you an instruction, for example, to pick up the candy and put it above the fork, say for example a fourth object is the fork. So I've basically given you an instruction, oh, pick up the candy and put it above the fork. Now, let's say if it's a tabletop thing. The meantime, to initiate an eye movement to the candy, to the target candy, because candy is the target object in my instructions, the meantime that you will observe, or that the researchers will observe from the participants to follow these instructions, would actually turn out to be much longer if the display contains a distractor object. Suppose that distractor objects basically shares the initial phonology with the target object. So suppose one of the objects is candy, the other object is candle. When the participants are looking to follow these instructions, they will actually take a little bit more time. This more time will basically be indexed in terms of the confusion or the ambiguity that has been created. However, if there is no such object, say for example one is candle, the other is fork, the other is tablet, the other is bottle. Now you can see among these four objects there is no confusion. None of these objects share initial phonology, and therefore the confusion will be much less. Now, just a moment. What is this, idea, or say for example, why are we talking about initial phonology and not the middle of the object or the end of the object? Now, the thing is, if you notice, if you pay attention to this, you will see that the speech is a signal that unravels in time. It unfolds in time slowly, and when you are trying to understand speech, what we are basically trying to do is we're basically trying to start listening and interpreting that starting from the initial onset, initial voice onset. And when you're trying to understand this from the initial voice onset, basically what we are trying to do is we are opening up the number of candidates from there. We are so for example, once I am trying to say, let's say cap or catch, or let's say if I'm trying to say cat versus caterpillar versus cattle. Now the thing is, when I start with this, when I say ka, I basically have a very large pool of objects that start with ka. So my search space in that sense from the mental lexicon is very large. When I say ka, then it basically becomes slightly narrower because ko and ka etc. sort of go out of there, and only the objects in my mental lexicon, or only the items in my mental lexicon that start with the phoneme ke will be searched from. And then cat, when I reach the cat, so everything like cap and candle etc. will be switched off, and everything that sort of has the initial cat sound will be searched upon. So basically what happens is that given that spoken language comprehension is a matter of a signal being interpreted in unraveling in time, therefore what happens is that it takes a lot of time for individuals to follow these online auditory instructions. And this is basically the fact that some of these studies have utilized to tap into this process and see whether parallel phonological codes for some of these target objects get activated and create a bit of confusion for these bilingual participants. Now, an interesting, and this is basically what I was talking to you about, that this insight that spoken language, or say for example when you start understanding spoken language, it activates a bunch of candidates that shares phonology. This is basically the cohort model of lexical access, which I have taught about in my course on psycholinguistics. You can go and refer it there from Marsland and Wilson. The model basically came from there. It is a very interesting insight that, as I was saying, has been employed. Now, the visual context, if the visual context of a display has been found to have, impact the participants' eye movements while understanding and following these instructions, obviously this can be, utilized to check for whether parallel phonological activation is there or not. Now, let's look at some of these studies in more detail. Now, Marian and Spivey in 2003 employed the eye movement tracking paradigm, referred to as I said earlier, the visual world paradigm, in 3 bilingual studies to investigate whether the activated cohort also included representation from the non-target language. Now, this is basically what these researchers were after. As I said, when you are a monolingual, the number of candidates that you will activate when you start, say for example, if I am an English-speaking monolingual and I am saying candle, cattle, cap, etc., etc., as and when I am sort of unraveling this signal in time, I am basically reducing the number of activated candidates and so on. But this I'm doing as a monolingual within the language set of English. Suppose if I, and which is the fact that I am a Hindi-English bilingual. Now when I'm listening to instructions in English or I'm listening to instructions in Hindi, every time I start with ka, I can go either side. I can go to, let's say, capital, cattle, caterpillar, etc. Or I can go to, say, for example, katha and this and that, katha and all the sounds in Hindi that start with the initial phoneme ke. Now, what will this do to my comprehension system is that it will sort of confuse this by making available activated candidates from both of my mental lexicons. This is basically the question that Marian and Spivey in 2003 were trying to answer through 3 of their studies which were performed using bilingual participants. Let us dig deeper into these studies now. Now, participants in these studies included Russian English bilinguals having a weaker English, and their first language, as I said, was Russian. These participants were seated in front of a board with 4 objects in it. For example, one of these objects could be a stamp. Now, they were receiving instructions, let's say in a Russian L1 condition, they were receiving the instructions in Russian. For example, put the stamp below the cross. Pole markiu ne krestika. So this is basically the Russian for put the stamp below the cross. In a L2 English condition, they will receive the same instructions in English. The idea here is that whether, as I was saying, when they are listening to Russian instructions, corresponding English lexical candidates are getting activated or not. When they are listening to English instructions, corresponding Russian lexical candidates are getting activated or not. Now, in a between language competitor condition, in addition to the stamp, which is the marku in Russian, the board would carry an object whose name in the non-target language would share the word initial phonology with the target word. For example, as I said, put the stamp below the cross, and Poloye Markiu Niekrestika is in Russian. Now, Markiu is a stamp in Russian. So, what basically could be done, and what is precisely what these researchers did, that with Russian marku as the critical stimulus word, one of the distractors object that they kept in the display was a marker. Now, marker is actually an English word, whereas marku is a Russian word. Technically, if there is no parallel phonological activation, if phonological candidates from the non-target language are not getting activated, then there is no reason for the participants to get distracted by the presence of the marker in the visual object display. However, if both the lexicons are activated, if both the the phonological candidates from both these lexicons are activated, then there is a chance that the participants might also get initially distracted with marku and marker, although they are different objects and they are from different languages. Now, the remaining two filler objects on the board were dissimilar from both Russian and the English names of the targets. Now, additionally, they actually included a control condition as well, where none of the three target objects names shared similarity with the name of the target object in either language. The authors also included just a within language condition, wherein the target word and its competitor belong to the same language. Say, for example, when they are using, when language is English and the target object is a marker, then the competitor object could be from within English and it could be a marble. So there is a within language competitor condition and there is a across language competitor condition. Here you can have a look at how the visual display looked like from the Marian and Spivey's 2003 study. You can see here that the marker is one of the objects, the keychain is another object, the disc is another object, and the stamp is another object. Now, if they are listening to the Russian instructions, Poloye Marku Niekrestika, then they will get distracted between marku, which is the stamp in Russian, and marker, which is marker in English. Or even if they are basically listening the instruction in English, let's say put the marker here or there somewhere, and marku is Russian, if it is getting activated, they might initially get distracted with this. So these two are the critical objects here, marker and marku or stamp, whereas these two are not matching to either of the language conditions, and therefore they are sort of just acting as filler or distractor items. Now, the dependent variable in this paradigm was always the proportion of trials on which the eye movements were also made to the competitor object in comparison to the filler object. So typically what happens is, and if you look at the data that these guys plot, is that they will basically plot the proportion of fixations on the target object versus the competitor object, target object, the competitor object, and the distractor objects. Typically what you would see in their analysis is that there is obviously a higher rate proportion of fixations on the target object, but there are also relatively higher proportion of fixations to the distractor object as compared to the filler objects. Now, given that these participants in our studies are also fixating on the competitor, the phonological competitor, would give us a hint of the co-activation of this object's name in the non-target language during the spoken word recognition process, during the time when the participants are actually trying to follow the instructions and move the cursor around, or say for example move the object around on the visual display. The three studies that were conducted by Spivey and colleagues actually differed from one another with respect to the care that was taken to prevent the participants from becoming aware that they were taking part in a bilingual experiment. Now remember, in the current chapter as well as in the previous chapter, we have seen that when participants become aware of the purpose of the study, they sort of will unwittingly already activate the non-target language. And if they have already activated the non-target language, we cannot actually actually interpret any of these results in terms of that whether there was parallel phonological activation or not. Remember Grosjean's language mode theory. The idea is that if both languages are relevant in a particular task or in a particular context, then both languages will anyway stay active, and in that sense that cannot be interpreted as an evidence for parallel phonological activation. So in Spivey and Marian's 1999 study and Marian and Spivey's 2003 study, the same bilingual participants participated in both a Russian L1 and an English L2 condition in separate sessions. Therefore, it is possible that in these two experiments, the participants would have suspected the bilingual nature of these experiments and therefore would have unwittingly increased their activation level of both the lexicons. Hence, we cannot really interpret whether parallel phonological activation was actually at play during these experiments. Now, given that the participants' both lexicons were active, in order to be able to conclude that the recognition of spoken words is language non-selective, evidence of cross-language competitor activation should ideally be looked under testing circumstances in which the participants have absolutely no idea that they are participating in a bilingual experiment, or they are participating in an experiment where their bilingualism is being tested. Typically, or the best situation for these experiments to happen would be that the participants would stay in the monolingual mode, but while staying in the monolingual mode and sticking to the base language, as Grosjean would say, they are still amenable to influence from the phonological activation in the non-target language. That will be the best test. And this is basically what Marian and Spivey in 2003 did, because they installed a condition by testing different groups of participants drawn from the same population in an English L2 and a Russian L1 experiment. Now let's move towards the results. In all of these three studies, the bilinguals actually showed that within language and between language competitor effects were clearly present. They made more eye movements to within language and between language competitors than to filler objects, which basically tells us that while obviously there is competition in the within language cohort candidate items, say for example between cattle and caterpillar and everything that starts with CAT, there is also competition across the language. Across, say for example, there was also competition between marku and marker, which are actually lexical items from the two different lexicons of the individual. Now, control groups of monolingual English speakers actually showed competitor effects in the within language competition only, ruling out the possibility that between language effects in the bilinguals might just have been an effect of poor stimulus selection. See, given that these monolingual English speakers did not know any Russian, obviously they will not be amenable to cross-language activation from the other language, and therefore because they are not showing these effects and the bilingual Russian English participants are showing these effects, we can actually safely say that the effects that are observed in this study are actually effects resulting from parallel phonological activation in the two languages. The within language effects converged with Tannenhaus and colleagues' 1995 results, and with also other evidence during speech recognition that the input activates not only lexical candidates from the same language but also a set of lexical items similar to the target word, which is, as I was saying, something that we have seen earlier as well. Now, the between language effects actually were the critical effects here. The between language effects actually demonstrated that the cohort of activated lexical representations using spoken or auditory input basically includes elements of both the target and the non-target language. This finding therefore indicates that the spoken word recognition is also language non-selective and that there is parallel phonological activation due to auditory input as well. Interestingly, the between language effects sort of varied between the different studies that were conducted by Marian and Spivey. Now, for example, whereas Marian and Spivey 2003 and Spivey and Marian 1999 observed them in both languages, Russian English and English to Russian, in a monolingual mode condition, they only materialized when the task was carried out in L2 English. This basically implied that the competitor's interference that was obtained was much stronger from a stronger L1 to L2 than from a weaker L2 to a stronger L1. Now this is interesting because what we are saying here is that the phonological codes are basically much more highly activated in your dominant first language rather than in your non-dominant or weaker second language. Also, we are basically assuming some difference in strength here, because we are saying that, let's say, assuming that both of these things are activated, there is more influence from the dominant language to the weaker language than vice versa. So this observed asymmetry also is a very robust phenomena and has been replicated in later studies as well. Let us try and understand these effects in some more detail. Now, while in the previous lectures we have discussed the SOFIA, a model that includes phonological representations of different sublexical word units, phonetic features, phoneme clusters. So it starts with K and CAM, etc., etc. So all of these different units of phonemes. Now, basically, we can also, going forward, try and see if there are any other models that are explaining these non-selective phonological activation effects. Now, in SOFIA model, whenever the auditory input is presented, the corresponding phonological representations would first get activated, then the activation would be transmitted to the orthographic as well as other phonological notes, and this is basically how the thing will move ahead. You can refer to the previous lectures where I have discussed the SOFIA model in much more detail. Now, it is plausible that this model can account for some of the phonological activation and the language non-selectivity observed in some of the studies we've seen so far, the Marian and Spivey studies. Another model that could possibly account for the language non-selective phonological encoding would be the bilingual interactive model of lexical access, which is also referred to as the bimola model, which was put forward by Grosjean in 1997. The bimola model was developed specifically to account for spoken word recognition, and this was developed as an extension of the trace model, which was a monolingual model of spoken word recognition. You can refer to the trace model from my previous lectures in the course Introduction to the Psychology of Language. Now, in this model, the auditory features, phonemes, and spoken words are represented in three different layers. Here, the feature nodes are shared between the individual's two languages, whereas the nodes representing the phonemes and whole word forms are organized into different language subsets. You can have a look at the representation of the bimola model here. You can see that while the features are common across the two languages, the phonemes from language A and language B are separately organized. So are the words from language A and language B. You can see that this model follows pretty much the same kind of activation mechanism, same kind of processing assumptions as well. So, for example, there is lateral inhibition within the level. There is activation and inhibitory connections across the adjacent levels as well. Now, so as I was saying, just like SOFIA, in bimola, the activated nodes at different levels can activate and inhibit nodes at the adjacent level. Also, there is within level lateral inhibition, as we have seen in the SOFIA model. However, the bimola model restricts lateral inhibition to units of other language as well. So this is an interesting difference between the SOFIA and the bimola model. Also, in the bimola model, the two word subsets receive a different amount of top-down pre-activation based on the external information that specifies the base language. Remember, according to Grosjean's language mode theory, the base language is the one that is most contextually appropriate and that is the most active in any given situation. So already when you are starting in a particular context of conversation, doing an experiment and so on, one of the languages will be slightly highly activated as opposed to the other language. And this is the initial assumption in the bimola model as well. Now, moving forward, once a word or a phoneme in a subset becomes activated, it sends a small positive signal to other words and phonemes respectively in the same subset. This way, subsets corresponding to the target will always remain highly activated. Now, in such a setup, once the model receives an auditory input, it increases the activation of the phonological representation in both languages, first at the language independent level of phonetic features and from there higher up in the system. So this is somehow, I mean, this is basically how they are trying to explain the parallel phonological activation in the spoken domain, as we have seen. Now, this model has been successful in being able to simulate two important effects. First is the unit similarity effect, which is basically that a phenomenon that a unit, for instance, let's say a phoneme presented in one language and sharing properties with the unit in another language will also co-activate the latter. So as I was saying, so if I have to speak something with ka, and I started with ka, say for example candle, cap, cattle and so on, or say for example I started with in Hindi kamal, kokila and so on, given that the initial features are shared across the languages, the initial phoneme feature ka is shared across both the languages. As soon as I say ka, candidates from both the languages will become highly activated, and this is basically the unit similarity effect. The other very interesting effect that this model has been able to account for is the base language homophone effect. The idea is that in the base language, if there is an item in the other language, let's say the non-target language, which is similar to the, or which is homophonous to the item in the base language, it will basically become slightly more difficult to process, or it will basically become more difficult to process this. All right. So in some sense, we have basically seen that parallel phonological activation also exists in spoken language comprehension as well, and which basically sort of brings us towards the conclusion of this chapter, where we are seeing that as in production, in comprehension as well, there is a parallel activation of both the lexicons of a bilingual. Both models, Sophia and Bimola, are obviously able to partially account for these effects, although since Bimola was specifically designed for this purpose, it seems to be the more favorable choice, or for more favorable candidate to explain and understand these effects. With this, I will conclude this lecture, and I will move on to the chapter on language control from the next lecture onwards. Thank you.